Okay, checking audio. 1, 2, 3. Sounds a little quiet. Move the mic a little closer, I guess. Okay, that sounds better. All right. So, ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy, where we are building a game with no game engine, and we are in kind of the wrapping things up phase. So, let me get into this. Okay, I know what this is. I know what this is. So this was after hours. This was after we finished this stream. I'm trying to do boring things after stream. So there. Okay. So last time we were getting the bubble, breaking it down so we can add multiple bubbles. Blah, blah, blah. This is fun. I think I've decided how I want to do this. Automated to upload to an alpha test branch. Yeah, so that was a big thing we got done last night. In the of the build into Steam, we now have all that done up. So in our old make file, we now have a debug, release, and Steam build. And then there's the Steam upload, and we've got all the credentials worked out so that I can do this from this script in either account that I tend to work from. So that's all working great. Finally. Finally. So now it trivially uploads to an alpha testing branch that I use, which now only takes me a few minutes to run a full build up the chain and get it working. So that's great. Next step I need to do on that line is add my son's Steam account to the test branch and make sure that it works and test on his laptop and account. So basically make sure that all the dependencies, that there isn't like dependencies on my computer that aren't on his computer. Like it should be dependency free. It should just download the 2 files he needs, which is Steam, which I can't seem to work around, and everything else is mine in a single file. So that's a task sometime this week. As long as it works from a clean install on his machine, I think we can call that good. There's so much Steam stuff to do though, like Steam Store. I actually started looking into this stuff today. There's a whole bunch of images and things that they need, and I've started typing up descriptions. Actually, such a pain because every store, every image, everything needs a different size image, and they're all weird sizes. Like none of them are standard sizes for an image. It's bizarre, but you know. Steam Store page updates need to be done. Images, text, tags. Yeah, I was reading up documentation, and everything's in different places. Like, you want to change this, that thing that's going to show up? On the Steam store, oh, it's over here. No, this one's over there. So I'm trying to figure out. I type something in, go look at it on the beta store page, and it doesn't look right. So I want to go change it again. But which tab was I on when I changed that, and which sub menu of the thing? So it's all a little bit tedious, but we'll get there, etc. So that's something I'm working on in the background. The other thing we did last night after hours was the logo in game had a black background, which with the chalkboard doesn't look right, so we just made it an alpha background. That's all I did after hours. So today is 8 days away from a good old United States Thanksgiving. At which point I will get to eat carbs again. That'll be wonderful. Looking forward to that. Bubbles as... Hey, JTL. Good morning. Or good afternoon, I guess. A class or a struct. Array of bubbles. Find parent-child relationship. All processing. Maybe 6 to start. An array. Right click to pop. This one's gonna be a little bit interesting. I need to be able to terminate an action sequence. And it should clean up all its resources. Animations, sounds, subsequences. I think those are most of them. That's actually probably the hard part here. Which is unfortunate, because it shouldn't be that hard, right? To start, just disappear and play sound. Maybe sprite animation for pop. We'll see how far we get. Maybe refactor scheduler, use the flags like the sound tool. Action sequence animations. Use their flags like the sound. Cool. Okay, just some things we need to think about. So this may actually be the biggest task today. This one we'll probably have done in an hour or two. Because we do spend a lot of time playing with look and feel these days. Because that's kind of where we're at. This isn't fast and dirty. We need it to kind of look good. But we need to be able to interrupt any animations that we have in the middle, which is not a thing we've ever needed to do before now, so that could be fun. Interesting. Okay, so that's our plan for the day. Dun, dun, dun. All right, let's see what happened. I had done some testing last night on the Steam build automation process. So I put some code changes back into the stash. So now they're coming back out of the stash. And I don't remember what they were. I need to move the branding stuff out of this folder. Journal's fine. Okay, this is where most of the work was we were doing anyways. Do I remember what we were doing? Oh. Reload. Guess we just pulled everything out of the stash. Okay, a bubble passes the applying parent through, which is fine. It keeps track of the quad, the velocity, the fade rate, and picks itself a random color. Okay, so quad gets the parent. Okay, I don't want to do it this way. Initialize. That's what we're gonna do. M_URG. There we go. Which means we can declare the array much easier. Quad.set parent. Yeah, sure. Hard code for one for now. That's fine. Okay, set our parent. We disable the bubble itself. Set the texture. We set the UV. We scale it randomly. Then we pick a random color, which happens here. Velocity, we're going to randomize, and fade time will randomize eventually. font size. Set color. No, instead of result, we're going to use random color. Set color equal to our random color. There we go. Velocity X and Y. Do the next float that's somewhere between, I don't know, 50 and 100. We'll see how it looks. Now this is not quite true. We're not going to be sticking with this at all. Do we have CMAT in here? I don't remember now. We do have CMAT. Okay, great. Angle. Next float. Will be between 30 and 60 degrees. Do I have a math? Do I have degrees to radians? Degrees to radians. Radians 2 degrees, why not? It's already declared in math, I can never remember. Okay, good. Does math declare pi? Why is pi global? Yeah, should be there. That's gonna break a couple of things. Okay, math.cp. Really should use this class a lot more for things. Let's see here. Well, this one's just the opposite. So degrees divided by 180 times pi. Wow, a couple of typos there. Jeez. Okay. Radians times half of a circle. Degrees times that. Yep, there you go. That's going to break a few things. We put it in global for some reason. That's all right. It means, however, that bubbles needs math. Okay, we're initializing it. math, degrees to radians is our angle. Speed, you are in G.2 next float between 50 and 100. We were moving 100, 100, which is like 150-ish. So 50 will be very slow. Now we can compute our initial velocity, which is speed times cosine of our angle times sine of our angle. Now, a couple more bits we want to add. So this is going to be moving down and right no matter what. So if you are in G.2 coin flip, del x equals minus velocity of x. We'll do the same thing on the y-axis. If we do a separate coin flip, so now we'll put it in one of the 4 quadrants for all the bubbles. Fade time, you are in G. 1 to 3 seconds. We'll just see what it looks like. Set the velocity. Color change time. Okay, so each bubble should be initialized with a random look and feel. It is initialized. Oops. There we go. That's better. Anything else? Oh. Okay, so bubble. Enable. Disable. We can do these all ourselves, but it'll flow a bit better if we don't. Just give ourselves a little bit of a pass through to make it convenient. Because then we can change the way we do things if we want later. M underscore quad. Is that what we called it? So we just call it quad now. Dot enabled equals true. False. Easy. Okay. Start color change. This is the fade, so that's fine. This part can be part of enable. Okay. Blah, blah, blah. No. No, 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 I'm wrong. It's 3. Sequence point to set immediate. And what we need here is underscore bubble dot start color change. So it's going to fade in and then start color changing. That is going to happen. Okay. Fade out, we'll come back to it later. Update. Okay. Is enabled. I may keep track of enablement separately, but for now we'll use the one in quad. Um, just gonna pass things through mostly. So this update bubble dot update bubble dot render in the view projection matrix. We're gonna make this all an array later. Okay. We'll come back to that in a minute. Okay. With quad enabled, then we do things. We get our position. Delta T, we can get that one time. So let's double DT. We never have to calculate that again. And then we update position. Okay, so I have to do that. So many little things. Update. There it is. Update position. We're just pushing functionality down inside the bubble itself. Start color change. Pick random color. This is where we separate it. Okay. These basically just go into the bubble. As further processing. We can even make those private. You know what? Yeah. Okay, come back to that. Okay. Oh, this might need to be public, though. Let's see here. Where's pick? Random color. Pick random color. Which means we need uniform IMG. Okay. Oh, yeah. Color. Pick random color. Given nothing. Random color back to result, since we're doing it this way. HSV. Pick random color. Okay, slowly, just putting things where they belong as we think through all of the different flows. Hmm. We'll come back to that notion in a minute. Okay. We've made these private. Where else I think we were already set. Okay. What else? Maybe just leave that linear. Fade out, update, render, set bounds. So each bubble needs this, basically. A lot of duplication of data. Hmm. Um, I'm not too worried about it. It's fine. It'll be fine. Let's see here. So float. We can make this static. Try to reduce some of the duplication of data. X0, Y0, X1, Y1. These are static. We recruited them statically. You know what? We can actually simplify this quite a lot. All we really need is a width and a height, since these are all contained. Float height. Bounding width, bounding height. Done. Bounding height equals height. So when we set bounds, bubble dot set bounds width and height. Bubble move to. Update render. Move to float x. Float y. Okay, nice little bit of refactoring, hopefully. Now, update position. We have a radius. We already have this. S underscore bounding width. Easy. Is that it? There's no way this all builds. So let's just see where the errors are. Okay. Oh. It needs to be math. Okay, so that's broken ease. Who else? Oops. Float, right, float, right. Ooh, uniform RNG also. Okay. What else have we got? Probably game scene is. Yes, thank you for telling me about that error again, just because it's included from another location. Game scene. Here we are. So wherever global is. Yeah. Airplane. Thanks, math. Okay, there should be a lot less errors now. That should fix most of our refactor there. There are probably lots of other math things that we should move into the math that we're like just kind of doing in situ right now. We'll come back to all of that later. Okay. Table gets its initial color. Instead of underscore bubble, we just do that. Everything's off alignment again. Pretty sure that M underscore U are in G. Okay, so it's add child. That goes the other way. That's great. That's actually great. That means we don't. Oh, that's not as great. Actually, that's fine. Insert print not equal to null. Insert underscore URNG not equal to null. Then we say parent to add child this. Okay. Oops. Underscore quad. Okay.
You know that. You're almost, you know that.
Quad is enabled. Okay, almost there. It's at least building. Ooh. S underscore down to H. Okay, that makes sense. All bubbles exist within the same bounds, so it's fine. I don't know. We set up some initial value. It doesn't really matter. Okay. Do you have any particular visions for the 4 books on the table? It would be good if there was a large number on the front of the cover. But I know that makes the animation more difficult. But otherwise, no, not really. Like I said, color choices, etc., I leave up to discretion. Any decorations or anything, whatever. I'm not too picky. Leather bound is probably a bit pretentious, but I mean, they already have much richer wood stuff than we ever had when I was in school, so maybe yeah, I don't know, whatever kind of notebooky that looks okay in an animation. Again, if you send me any textures, I'll crank them in and we can see them live. The unanimated part is probably the easiest one to get started. It's definitely the front cover that's the big pain in the keister. Let's see if we get that one bubble to show up. If we do, okay. Awkward. Oh, not m_orng, just the one I'm passing in. There we go. Oops. That's a silly error. They should be different colors, but yeah, if there's a number as well, just in case of like color blindness, that would be wonderful. Alternatively, and this is, I don't know, this would be fun too if you only wanted to make one notebook on the table that was colored in grayscale, so you can build it up in whatever color you want. Nope, never mind. I take it back. For that to work, you'd have to build the book in 3 parts, which we could do, but it's kind of reinventing the wheel. As far as layout, like design of the book, as long as it looks like it's got that same orthographic projection, I really don't care about the thickness or the offset from the spine or the curvature of the spine. Like those numbers don't matter as long as the book sits there and as long as when it animates open, it looks okay. I think that's the main concerns. There's really no interaction with notebook other than the pen sitting on top of the open notebook. So yeah, that insert was on the wrong thing. Oh, there's our bubble. Let's head it off. So we picked an angle between 30 and 60. That angle so we didn't want like the horizontal one, so the bubble just went left and right. So we picked between 30 and 60. So at least have some depth to its ricochets. And then hopefully we picked a quadrant. So this time it started off down negative. We don't want them all that way. This won't exit properly because of the bubble. We don't have that terminate command yet. So let's run it again and just see if we get a different quadrant of travel initially. It does. Great. And it's slower and okay. Perfect. So that refactor is done. Did that. Okay. Bubble now has its own class and processing inside the doodad. Time to make it an array. I think I've got these files open on my other account, so I can't just do things. Okay. Oh, the other thing we did, journal. Also move pi from global to math. So we're going to add everything, then we're going to remove it. Get store staged. Don't want these files checked in. In fact, there's probably files we need to get out of here for branding. Moved pi from global to math. Bubble now in a class inside the doodad. Still looks about the same, but we're getting to the part where it's going to change. Okay, thanks. Yeah, sure. And even if you want to change their sizes a bit, that's fine. As long as they fit on the table. Like they just need to be well. Oof. I mean, I've already done the math for the click area of the current book, so maybe don't mess with the size that much. But the curvature of the spine can be, whatever. Not. You can mess with the size a bit if you want. I don't know. The click is already calculated. Okay. So now we're going to make it an array of bubbles. So if we go to bubbles, instead of m_score bubble, static constant num bubbles. Let's start with 6. There we go. And here's the fun part, m_score bubble. Int index equals 0, index less than doodad chalk bubbles, number of bubbles. Increment. We have an update. This really isn't that bad. Set bounds. That's basically it. So what are the odds it just works? Shouldn't be too hard to keep the sizes in general shape. Yeah. Because basically we're testing the front rectangle, 2 triangles on the extruded vertical side, and then 2 triangles on the top face, because they're skewed rectangles. As long as those 1, 2, 3, 4, 5, 6, 7 corners line up, it should be fine. And basically the 7 cover corners are when the cover is shut. The top, well, that's more than 7. No, it's, yeah, for the top 4, and then the extruded down 3 points below those. As long as those 3 points more or less line up, it should be fine. Or 7 points. When it's open, we use the same math. We're not gonna change anything there, just because it's open or closed. Okay, we had 1 bubble. Now we should have 6. Oops, I know what happened. We're getting out of here. Didn't give enough room for more children. Yeah, I've got to set up like a YouTube channel. I need to get like a tutorial video. I got to make like a trailer video. Got to make banners and different logos for the different places that Steam sticks it. This is probably going to crash. Nope, there we go. Now we can do a few things here. We can make more bubbles. We can have more size variation. I think the bigger or smaller it is, Maybe we make them smaller. No, that's gonna crash. That's fine. Okay, so at least we're there though. Like, it scale 0 and let's go small, small. Why not? Right? I feel like the speeds were a bit much. So let's go 40 to 100 pixels per second velocity. What else do we want? If they're smaller, oh, I know what another thing I want to do. Maybe we can have more of them. 6. Let's go 12. Then one more thing we want to do is all of our colors. So there's the enable. Let's go from 0 to see what, okay. Pick random color. Here we go. Result dot alpha equals 128. We'll just make all colors partially transparent. We should probably do a tidy and debug. Bubbles should bounce off of each other. They probably should. That would be cool. That is maybe a harder, well, it's not that hard of a problem, is it? It's not that bad, especially since we have a limited number of bubbles anyway. Would they, would that be too, that would be so, look so good though. It really would. Maybe we do. Wow, when did this happen? Just trying to make your life harder. You know, it would look so good though. It really would. We could even do some conservation of momentum calculations. It'll be fun. Where the mass of the bubble is basically its radius. It's scale with radius, so you can use them as equivalent values. That would actually look kind of good, wouldn't it? Okay. But they can only start colliding once they were out. I like adding that alpha channel. Maybe even a little more. Okay, that's not bad. Not bad. There's no way it's going to actually exit the level properly for some reason. Oh, well, I know why the reason is. Never mind. Whoop. So we go to, oops. We'll go to start color change if it's enabled. So when we go in here to fade out, We're gonna cheat for now and just do that. Yeah, so it'd be an initial. Are you overlapped something else already? Once you unoverlap everybody, then you become collidable. That could be very nice looking. Let's see. I kind of want to delay so they. Ooh, these three are clumped though. Once they unclump, then they would become collidable. Maybe these big ones are too big. Maybe we'll go a little smaller even. Although this one is going to be very hard to see clearly in a smaller screen size. Okay. All right, well, that's gonna work. Okay. Where I agree the alpha looks good. You could even set alpha for smaller bubbles higher, so it looks like a 3D bubble field. 3D collisions. So you say alpha scaled with the scale itself. We could do that. So smaller would be more opaque. Well, this is where the remap function maybe gets done. Update position, start color change. Oh, here we go. We'll need this function eventually. We had a static function somewhere. Set bounds, nope. Pick random color. We set size, then we set color, so. Pick random color. Float remap. Float value from this range, x0 to x1, from that range to this range. Useful enough function, we'll just make it generally available. Okay, so we're taking this value minus, we're gonna start off by asserting that x0 is less than x1 and y0 is less than y1. To start, value minus the low x, the range it's currently in, divided by x1 minus x0, tells me basically what percentage of the way are we into this range, times the width of the second range plus the offset from there. Easy peasy. We can do math. So we're going to math remap underscore URNG next float from 0.5 well, let's see here. My scale range, scale. 1/4 to 1. I don't need this. We have m underscore quad scale x, I think. They'll be the same, so it's fine. We map from scale x from 0 to 1. So our scale is always in that range. Into the range from 0 to 255. Not 0. From 120 64 to 128. Maybe 32. We'll try it. Smaller equals further away. Yeah. Smaller is more transparent. See, but a soap bubble, the more stretched out it is, the thinner the soap layer, isn't it? So it'd be more transparent the larger it gets. No, I think some variation in the alpha would look good. And maybe it just needs to be random instead of. Is that backwards then? Those seem a little bit faint. We could just pick a random one. Our scale is small. Yeah, maybe we just pick a random one. MURNG next value between. I think 128 is about as opaque as we want to get, but maybe we'll go to like 64 instead of 32. Let's pick a random alpha every time. So they'll fade and come back in. Having it scale the size, I think, would be kind of fun, but maybe random is good enough. So they fade in and out a little bit. Not a lot. Oh, it's so calm and relaxing. Which is the goal. You want something like engaging. So do I like a random color every time? Let's go back to this one. Remap. We get our scale, which is between 0.25 and 1. And we say it fits in here. Maybe up to this. Maybe we make it even more obvious. Let's go all the way from. Let's try that. We should make it very obvious which ones are more or less opaque. So the bigger ones are more opaque, which we want the other way around. Although those small ones don't look all that. Scale X? Oh, shoot. Okay, we can do this still. This is fine. M underscore size, which let's scale factor. Easy, easy, easy. Set size. This scale is this thing. What's M underscore scale factor? There we go. That would be different. But the bigger ones put more pixels on the screen. So the more alpha, also the less obstructive it is, even though it's larger. Maybe. So right now, the big ones should be dark, and the small ones should be more transparent. Yes, which is backwards of what we want. So we just want to do this 1.0 minus, and maybe, yeah, well, maybe 32 is too much, but it's more pixels, so it should be more visible as a bigger entity. Collision detection is not bad in this problem, because everything in it is a sphere. We're already handling the boundary blocking. So now the small ones are opaque and the large ones are more transparent. Maybe that's good. Maybe 32 is a little bit too transparent. Maybe 256 5 is too opaque. Just narrow that range a little bit. So I'm gonna go to 64 to 192. Easy, easy. Smaller equals further away would be, again, not hard. And in fact, it would simplify the collision detection. But I think what we want to do is try to keep everything coplanar on the chalkboard to maintain that illusion. Ooh, a train. A train. Can we do a doodad with a train? I'm just trying to think of doodad ideas as well. So, maybe this could be a chalk drawing one. Train. Kids love trains. Steam engine, more specifically. Or it could drive off the top of the bookshelf. So they technically have different alpha values. Okay. One thing I'm seeing is a don't like this color shift, actually. I don't. I don't like it fading in. I like the scaling in. So maybe we only need 2 of these. 0 and 1. Oops. In which case, what? That doesn't taint our frames per second that much. We're still under a millisecond drop per frame. Okay. Do we want to do bubble collision? I kind of do. I think it would look really good. Even if bubbles now in an array, 12 bubbles looks pretty good. All the processing is in the array. Bubble collision. Yeah. Bubble collision. Detecting the collision would not be difficult. Detect which bubble was clicked. Let's start with this while we ruminate about collision. Preservation of momentum could be fun. Okay. I think that would be a good resolution for a collision. Let's do this. Detect which bubble is clicked. Now, we right click, blah, blah, blah. So what we need then is the way to ask slate X, slate Y. And this is such a small collection, we are not going to do anything fancy with like space partitioning or anything. We're just going to blaze through the old array. Let's see how that looks. We're going to do this. X equals r dot x. So this is our center point. This is relative to where we draw it. This is our center point. So all we really need to know is actually, no, I think this needs to be screen X and Y. Button called something. I think it's right there. In which case, we're reading that does contain screen point. We just ask. We can allow people to pop more than one at once. That's fine. Or do this. Does contain screen point e dot x e dot y. Bubble number index bool. We click a bubble. Bool's false equals true. If not, click bubble. This. We'll see if that works at all. Hopefully that's close enough. Oh. Okay, so we didn't even do that. Bubble button, not bubble. Repeat this. Update position. Quad dot does contain screen point. Screen X, screen Y. Oh, I'm gonna private. That's a little awkward. We could make it a friend or something, but no. This is not protected, is it? I. right, well. We can just make a simple pass through here. Means screen point, screen X, screen Y. Return does contain screen point, screen X, screen Y. Then we go to bubbles. Contains screen point. That's awkward. Picture quad. It's definitely Boolean. No matter what I said before. Okay. Not bad, not bad. Okay, so if I click one, it says I got bubble one, I didn't get anything. That little fella's bubble two, bubble one, 8, 1, 8, 1, 8. Where's that little one? This little green one? Bonk. Missed. Maybe these are too fast. Bubble 0. Eight. Where's that little teeny tiny one? That's 1, 0. Okay. Seems to be working. Okay. That's that task done. That did not take as long as it could have. So that one's good. We'll now have alpha scaling with size. And right click bubbles, detect right click bubbles. Okay. All right. So bubble collision. boolean m underscore collidable. Okay, collidable equals false. This is an n squared, so we'll have to do 144 collision tests, roughly, as that's not quite true, but it is roughly that. It's actually more like half that number. It's like 72. We don't want them to collide until they're fully out. Then we want to ask, I guess this would be a static. Collide. Bubble A and bubble B. This is just a test for collision. Void mark as clear. Okay. Check for collisions. Clear bubbles for collision. Okay, I'm going to pause there for a brief restroom break. Not bad. We'll get into that shortly. Okay. I think we're back in. I do feel like my audio is a little quieter than usual. Okay. On top of the shelf. What about catapult, castle, or archer? Right click to and hold to aim and charge the shelf. That could be kind of fun. We'll probably have to limit ourselves. I think the number of doodad ideas are going to outpace my ability to implement them. Okay, so for each of these, if our bubble is collidable, if it's not collidable, we're going to do something. Bounds easy, easy. We'll do that. Okay. If the bubble is not collidable, then from other index equals index plus 1, less than that. So if we're not collidable, we have to say, are you overlapped with anybody else collidable or not? Is clear equals true if bubble collide bubble and other index. If clear equals false, if not is clear, break. Otherwise, bubble mark as collidable. Okay. So if a bubble is not collidable, we say assume it's clear and go through all the other ones and see if they collide. If it does collide, it's not clear and we break. It's not clear and we break. Outside of this loop. If we've gone through this whole loop and it still says clear is true, then we say, yeah, it's ready for collisions. Bubble is cleared for collisions. Then we can check the collisions. So let's see if that logs out what we would expect, more or less. Unused parameter A and B. I don't care about that. No return. That's. Ooh, actually, that's a good point. Let's just go ahead and implement that. Return result. Okay. A has a quad. Wait, so float radius of A equals this divided by 2. This is the width of a full rectangle. B quad rectangle over 2. Rad equal rad squared. Radius, sum of radiuses squared. Or let's see here. Float collision distance squared equals rad A plus rad B, rad A plus rad B. Okay. Then we say our actual distance squared we'll go and get these rectangles. Const rectangle RA equals a m underscore quad rectangle. Same thing with B. Rectangle A. Rectangle B. Distance squared. So let's get x sub A and y sub A and for B. Distance squared equals, what's here? Delta x equals x sub B minus, that doesn't really matter. X sub A minus x sub B, it's going to be squared anyways. Delta y dx times dx plus dy plus dy. And by getting our distance squared, we didn't have to do this multiply here, but this multiply here saves us from having to do a square root here. So slightly more efficient. It won't really matter in our application, but you know, if you care about efficiency, it's better to compare distance squared than just distances, unless you've already computed the distance for another reason. That is a plus. That should be a if our distance squared is less than collision distance squared, result actually it's one of the lovely cases where no matter what, we just return that. So the actual distance is smaller than the sum of the two radii they're overlapped. And we didn't. Okay. Probably tiny debug. We changed the memory footprint of the bubble. It now has a flag to say whether it's ready for collisions or not. So if two bubbles start off overlapped, we don't count it until they've separated. Then they're ready to test for collisions. This is like a special microcosm of an actual physics engine. Oops, not that one. I just want to run it. And all we want to see is that eventually we have all 12 bubbles marked as ready for collisions. Well, that's not a good index, but that's probably me being silly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Strongly suspect that's not right on multiple levels. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to go through the end. If index not equal to other index, and if they collide. This won't run very long at the start, so we should get. Well, firstly, I don't think the collision is working because There were two that were clearly overlapped. But they were marked as... Yeah, this just blazed through here and said they're not overlapping anywhere. Which is silly because we put them all in the same exact location. I expect several to... Yeah, that's no good. Each bubble, if it is not collidable, test the collision. That collision test is not working apparently. Sure. A not equal to null. B not equal to null. A not equal to B. Okay, we get both our rectangles. We get our radius of our two bubbles, which is half the width. Yeah, total of the two radii sum squared. Let me get x, y, x, y. Find the distance between the two centers. Sum them squared. They should collide if the two, if the real distance is smaller than our collision distance. Um, oh, well, for one, if the bubble is enabled, so we only check against bubbles that are, and, okay, fine. Other bubble equals this. Other bubble is enabled, and if they collide, because if a bubble becomes popped, it's no longer available to be processed again, so we should those all out. It's not clear. Oh, maybe it's is enabled. disabled. There we go. So we start off, all the bubbles should be in the same location. I think while they feed in, it would be nice if they appeared to come out of the same point a little bit more. They should spawn here. But by the time they're visible, they're already a ways out. They're all cleared for collision, even though these two have never been apart. Okay. Every bubble should be moved to the same exact location. Set bounds, is that before init? Calling it here. Okay. Let's do a little thing here. Let's get one more thing. Need a function called set velocity, float, velocity x, and velocity y. X equals velocity x, y, init. We are going to start two animations. I'm going to try one anyways. Over the same amount of time, while it's scaling, we're going to do this. Set range from 0 to underscore velocity x and underscore velocity y. This is our start, our stop. Set velocity x and y. So we are going to speed up everything will start in the center. Get faster. Oh. We'll try that. Oops. Oops. I just feel like they're too far away by the time they're visible. So if they start off slow and then accelerate as they go away from each other, it might be better. Which still does not fix the collision issue. We can do some debug printing around it a little bit. Okay. That does look better. But those two were never uncollided. So, what is going on here? Collide. Collide. A is at X, Y, and a radius. B is a circle here. So we're gonna get like 72 of these things printed out. Radius A, X sub A, Y sub A, radius A, B, B, B. Which is really the test of, does this number less than this number, which is our distance squared, less than our collision distance squared. Like I said, we should see 70 of these. 7A, oops, we should, oh, no, we can't. It'll be fine. The numbers don't make any sense. Like the first frame, they should all be at 0, 0. And even though we're scaling them in, like we're only testing against that final size. We're not testing against. Oh, maybe that is the problem. They're all scaled to 0. So we can only use this for position. We need to actually store the radius ourselves. Okay. Maybe that's our issue. So we're storing collidable float m underscore radius. In which case, that may be just fine. When we init, scale factor m underscore radius equals width over 2. Set center at radius. W over 2, yep. This collide could be better. These are const. We aren't modifying anything, we're just testing. Okay. La la la. The update position, we just use underscore radius. We've pre-computed it. EZ divided by 2 anywhere else. But that one's fine. We can keep those ones. This one. That's it. And then we go to collide. And that's independent of scale. As we animate in. Nope, that's not gonna work. Well, it might work. Okay, let's try this again. So I don't want them to not collide when they're scaling. Okay, so I think that actually is working. We just need to remove that log statement now. We fixed it right when we put in the log statement. I don't want this one. It's the other log statement I don't want. Not that one. I'm fine with those. This one. Okay, that gives me some confidence that the collision detection stuff is kind of working. I'd be curious to see how frames per second go when those bubbles come in. Some of them are colliding. Boom. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Interesting that they all came in that order. I would expect them to come in potentially different orders. Try it again. Oh. Did we put a break in a weird place? 4, 5, 6, 7, 8. We're waiting for these two to untangle. There it goes. Boom. Okay. So I think we just have to put in here. If is clear. We don't do this break. they should not be required. Yeah. As soon as they're clear, they should be ready to collide. So we should see them come in some semi-random orders here. But that's most of the hard part, actually. Right. 11. Oh, yep. Ooh, these two are going to take a while, if they ever do. Now we have 12 things. We could shoot them all off in more predetermined orders. They are diverging slowly. See, we are around 1 millisecond now. 5. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They are all cleared finally. Phew. Okay. Okay, so that's more or less working. Okay, check for collision. Much of this is going to be very much the same. For each bubble, we get the thing, if it's enabled, and if it's collidable, we go through here. It's not quite the same. If interesting. We have to check and make sure it is collidable. If it's collidable, if it's enabled, and if they collide. Good old collision resolution. Basically what this means is bubble 11 will always be marked as clear after the first time through this loop. Well, through this loop. bool. All first 11 clear equals false equals true. If we had to clear one, then the first 11 is not cleared. The first 11, wow, can't spell. If this is true, then bubbles sub num bubbles -1. Mark, that was collidable. If nothing else is colliding with it, it should be good. E level n. Okay. That's gonna clog things up. It's close to the same loop, it's slightly different. Is clear. Oh, we don't do that. We don't need this flag anymore. Okay. I don't see 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So why did 11 not clear? Oh. That's probably because first n. Let's do it full n squared. It only lasts for a few seconds. And only 144. It's not that bad. Save ourselves a few few simple comparisons, it's not worth it. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There. Okay. And we're still cruising along at a reasonable FPS, so good to go. Checking for collisions. If they collide, here's collision resolution. Let's break this out into a function. Clear bubbles for collision. Bubble specific. Okay, more bubble collisions. Resolve bubble collision between A and B. Okay. Resolve bubble collision between the bubble we're looking at and the other bubble. Basically it. Okay, hard part. A and B are traveling at some velocity and they happen to touch. There are different resolution mechanisms. Let's talk about physics resolution of collisions. The old scratch buffer. We have a shape. Shape plus maybe this is not the best way to draw it. What if it is touching another shape? They overlap. two shapes overlap. And they have a velocity vector. So object A and object B have different velocity vectors, and they can be very nearly incident. They could be actually incident, so that one is traveling along the same vector, but at a different rate when it catches up. They could be orthogonal anywhere between the angle, and the velocities can be completely different. One thing you can do is this happens in a moment in time. So t at time t. Two shapes overlap. And since we have discrete time steps, the moment of impact is probably not actually at time t, it's probably at t between t minus 1 and t. So the last frame we updated, they weren't overlapped. In this frame, they are overlapped. The real actual moment in time when they overlap, it's probably in between. So one thing we can do is say, give me the velocity of this, give me the velocity of that, and their current positions, and calculate backwards the actual t, the interpolated time t when they met, and rewind their physics and play it to that time. So basically split this range for these two objects into two pieces. So one thing we could do is split the time range t minus 1 t into two time segments, which are t minus 1 to the time of impact, and from time of impact to the current frame's time. Rewind, let's see here. Compute, let's see here, reverse the positions of the two objects. Since we have their velocity and we know what the last time frame was. Well, we don't, but it's fine. This would be a reasonable approximation. Reverse the positions of the two objects to the t minus 1 time frame. Compute the two steps of physics given the two time segments. Okay. So we can say rewind time from where we're at, where we were last frame, then compute the physics from the last frame to the moment of impact, then compute the physics, then do some resolution here, then compute the physics from this time, from the moment of impact to the current frame. If you are very serious about your physics, this is the right way to do it. Higher fidelity physics. If you want something that just looks okay, one thing we can do is compute the vector of overlap. So in other words, from the center of this object, well, in this case, we're doing with circles, so this is trivial. We take the center of this object and the center of this object, and we just find the direction, right? Then all we do is we move the two objects the shortest distance to unoverlap them both. So we'll take that distance and maybe we split the difference, right? Or we take their velocity vectors and just kind of scale things until they unresolve. velocities are updated in between the two physics seconds, 2 time seconds being processed. Okay. The 2 objects new velocities move the objects move both objects away from each other enough to not overlap. Okay. So this one is a lot more complicated. This one is a lot simpler. We just say, hey, how much overlap is there? Especially in the case of circles. Move them away from each other just enough that they don't overlap. So they're touching basically along this vector. And then compute their new velocities and keep going. For us, this one is probably fine. Especially at high frame rates. Even at 60 frames per second, we're moving, what, 100 pixels per second? So we're probably going to do the lower fidelity physics here. Compute the new velocities. That is kind of the tricksy part. I don't remember off the top of my head, because it's been a while. Don't remember off the top of my head. How to resolve that. Okay, sorry. I think I probably need to Google something here. Collision resolution with conservation of momentum. Basically, the short answer is we know their velocity and their mass coming in to an impact. And the velocity times mass needs to be equivalent on the outside. But I don't remember how to pick the direct, which one gets how much momentum. Only somebody, and these will be perfectly elastic collisions, so no energy will be lost. So let's see here, forces are equal. These are all two-dimensional examples I'm looking at. Why are they doing head-on collisions here? In 2D. I don't remember all the things that go into this here. So I'm just Googling here. Total momentum before the collision. Yeah, sure. Total kinetic energy. In 2 or more dimensions, momentum conservation and kinetic energy conservation do not provide enough constraints to uniquely determine the result of an elastic collision. Using equal ball mass, the conservation laws result in the following 2 equations. There are 4 unknowns, which is the 2 velocity vectors. But there are 3 equations. We have conservation of momentum, conservation of energy. We do want those both conserved. And the directions can be... I don't really want to give a force. I don't want to use forces for the collisions. They're both like this. They're both like this. We could cheat and just make them straight reflect off of each other. Conservation of mass, conservation of momentum. Conservation of energy, rather. So we have kinetic energy, we have momentum. We're not. Kinetic energy, let's see. That's velocity. Conservation of momentum on the X and Y axis. No, I don't want equal masses. So what we want right now is to know what their So each bubble has a float, momentum, and kinetic energy. And in this case, we're going to use radius. Oh, darn it. Float. Momentum along the x-axis, and along the y-axis outputs. Kinetic energy is a float, actually. Is that true? Hold on a second. Kinetic energy is 1/2 mv squared. Energy along a given direction. So it needs energy in the x-axis, energy in the y-axis. I think. Okay. The contents of Px equals radius times velocity x. Y. Energy on the x-axis equals our mass times our velocity squared. Half. 1/2 mv squared. Energy along the y-axis. Here we are. Momentum along the x-axis. Px, Vpy. Looking for energy, kinetic energy. Oops. Momentum APX. Momentum of object A along the y-axis. B. energy, kinetic energy. Okay, so the energy and the momentum at the end of both of the collision must be equal. So we are going to compute new momentums and new energies and decide how much to give to each one. So at the end of the day, float px equals apx plus apy. So if we're headed directly at each other, x, whoa, b, x. So if we're headed directly opposite each other, one of us have positive, one of us have negative, and when we hit, that momentum will be 0 if we're the same mass. Same thing for the total energy at the end. Float energy on the x-axis. Y. Okay. In a head-on collision, you know, we could cheat. Let's just do something fast and dirty, just to, instead of going down all this finished road. Let's do the worst possible thing. If they bump into each other, we'll just bounce them 100% off of each other in the opposite directions. Reverse. This is bad. Should not do this. We just want to see a response, which would tell us that our detection and everything is correct. Our velocity x equals negative velocity x. And y. That's going to be our initial collision response. Why are we overthinking things, right? Turn around, drive back the way you came from. It could be fun. Hey, Pat, how's it going? Welcome back. What's new with you? It's bad, but it works. Things don't look good when they collide, but those bubbles are indeed colliding. Yeah. They look better if it's a head-on collision. Orthogonal looks stupid. And high incidence angle, well, more coincident angles look terrible. One, two, three, four, five, 6, 7, 8, 9, 10. Okay. So, I think the collision detection is okay. Trying to get things in order. Grandmother passed away yesterday. Oh dear, I'm so sorry. The entire family's in an uproar on my dad's side. Uh-oh. Yeah, that's rough. That's no good. That's always a very emotional time for everybody. So hopefully it wasn't, yeah, I don't know. Some people pass away and it's like, you know, they'd suffered enough. The end was peaceful. Other people, it's just so sad. So hopefully it wasn't too bad. Hopefully you were able to be there. Yeah, I ran out of grandparents a long time ago. Honestly, I wasn't close to my dad's mom because she was really mean. Okay, and I have like 50 cousins. That's a lot of cousins. Not as many as I've got, but quite a few. 6 aunts and uncles, so she had plenty of other family to love. Okay. Mom's mom is still around though. Okay. It only has me and my little brother, so we're much closer. Okay. Still, like I said, it makes a bit of an uproar for everybody. And actually, the way that things are built out nowadays, when somebody passes away, it is complicated for the whole rest of the family. Okay, so reverse is wrong, but I think our collision detection is okay. Get our momentum, get our kinetic energy. Yep, lol. 1 sec, need some water. Okay, yep. Super cool. It has been too long since I've written a 2D physics engine. Let's see here. 2D circle physics collision resolution. Detection is easy. I don't want detection. Collision, circle collision is easy. Separating axis theorem. Collision algorithm detects a collision between two convex polygons. Yeah, nope, not interested. I want collision detection. Blah. Objects are moving pretty slow. There are a lot of stupid people on the internet, and unfortunately Google is no longer very good about picking the better better solutions anymore. I don't know if that's a result of their algorithm, and there's a lot of stupid people clicking on answers that are wrong. But it used to be pretty well quality filtered because people would look at things and be like, that's stupid, I'm never linking that on my webpage, and then Google wouldn't index it very high. But the ones everybody kept referencing, like, oh, this is how you do it. Find the normal vector between the two touching circles. Yep. Know that each circle will have its velocity vector flipped over that line. That's what I needed. That gives me the two directions. Oh. Okay. So I have to... Okay, so hey, info link into the chat. Boom. Elastic 2 dimensions. I'm going to put that also probably in here. Maybe we don't need kinetic energy. We compute the total momentum. We compute the vector between the two centers. The two centers. So we take okay. Float x, float y. We'll put that next to, oh, we don't have radius. Funny about reverses, how much, what a percentage of the time it actually looked like a semi-reasonable response. Okay, so we're going to get float. The normal vector x component equals a sub x minus b sub x y. So that's the vector in which they both touch. The math. Calculate the collision angle. I don't want an angle. Do I have to use an angle? I guess we do have to have an angle. We have math already in here. We've already have math in here. So y1 minus 2 oh. Along the y. I guess it's y then n. That's probably true. Use the collision angle, the ball's initial velocity and the ball's initial direction to derive its xy velocity in the new rotated coordinate system. Velocity 1, velocity 2, d. Initial direction. Hey, Ferris, how's it going? I'm learning Python. Okay, that's fair. I've heard I can't focus only on it. My fear is that I'll forget it, and what I've learned won't be of any use. Any advice? If it's not too much trouble, could you write it down? I'm using the translator. Thanks. Okay. Learning Python. It depends on your goals. If you have some specific project you want to work on, at work or a hobby, you should focus on the tools that help you do that thing. If you want to be a better programmer in general, I would agree that you shouldn't stick with Python forever. There are things that it hides from you. My personal recommendation for learning programming, not just project focused efforts, I say learn C and then common lit. C is low level enough that when you learn it well, you understand better what is happening on the machine, memory, and CPU, given the code you write. Lisp makes you think differently about your code and the AST. You may never use C or Lisp, but they change the way you think about programming. Then when you learn a new language, the fundamentals and what the new languages provide, you will understand better. I hope that helps. Again, it kind of depends on your goals. There's no point in learning C or Lisp if all you want to do is some Minecraft mods, right? Hopefully that helps. Obviously, there's a longer discussion to be had about all sorts of that related topics, but it's a very broad topic, right? Where are we? 3:30? Very broad topic. But you know, I'm not gonna type forever. Okay. Ooh, my back's feeling it today. What's going on here? All right. Which does remind me. They're so clever. Okay, never mind. Not gonna do that. Okay. Blah blah blah. So yeah, hopefully that helps. I don't see a response, so either the translation takes a while, which is fair, or well, I want to work on it, but I'm afraid I'll forget what I'm learning. This effort won't work. You won't forget much. You have to relearn a bit. It never takes as long the second time. It comes back quick. Once you have 2 to 3 languages, the rest come much faster. Okay, so we have the collision angle. Initial velocity u involves initial direction. Why do I multiply those by the initial velocity? Let's apply the 1D collision equation. Okay, I don't really like that solution, and me doing the math on stream to get what I want is not great. So I'm gonna follow this other link if it looks like it's okay. Reach ball, inner frame, if this, blah, blah, blah. What is this? Okay, not interested in any of that. Flash is broken, so that doesn't. Fine. Oh, why are people's treatments of 2D so bad? This one looks maybe better. Static circle collision. Okay, this person has some fundamental misunderstandings about math. Oh. Okay, this actually looks like a reasonable piece of code here. Alright, so let's go. Here's this one's better. This is a better link. Thank you so much. Anytime. Let me know if you have any other questions. I don't mind answering questions. So if it takes me a minute sometimes to notice your question, don't worry about it. I do check the chat semi-often, but sometimes I get deep into a thought. So just let me know. Okay, this one was better, I'd argue. I actually don't really like this one very much. Okay, so back to my looking. So first we're going to do is we're going to move the circles off of each other. So what this is saying is you take the two circles, you find the point in between them, then you move this off by some amount and this off by some amount along that same angle, along the direction where they're touching. I don't really like this one. Right now this one has a plus, this one has a minus. We'll see which ones we keep. Comment that out. Momentum. So this is this. The vector from one to the other divided by distance. Circle one radius, so. And the midpoint. Okay, float. X sub A. And Y. B, 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 oops. Okay, midpoint, float. X at the midpoint. What's X A? plus xb divided by 2 y delta x equals, that's fine. Therefore, a dot move to, we're going to cheat, we're going to move it to x at the midpoint plus radius, which I'm not sure I'm exposing either bubbles. Okay, x, y, radius of A, radius of B, radius x, y, radius x, y, midpoint. Okay. Move to midpoint plus radius of A times x of A minus x of B divided by distance. Does he clearly state distance is between the two circles? Is this common enough thing? Do we want to just put that in math? Let's get distance float x float y float x float y. We also have the distance squared option. But this seems to be happening often enough. We might as well do it. The square root of distance squared dx times dx plus dy times dy. Okay, so this is, oh, that's only the first part. Blah, blah, blah. Circle 1 dot y is, oh, that just flips those. Dx equals x of A minus x of B. this is dx. dy. Okay, then circle y1 is y midpoint plus radius of a times delta y all over the distance. B, instead of plus, it's minus. We want to basically move it the opposite direction. That's all that means. So step one, move both shapes away from center to the edges of their radii. Okay, easy peasy. So now we have our distance, which is the sum of the two radii. Oh wait, unless, wait a second. Hmm. Hmm. Don't really like most of these explanations. Part of the magnitude vector, fine. velocity of the first circle with masses of the two objects. Two times the velocity dot normal. Resultant velocity of the first circle. Let me flip it on the other way. Is that right? Kind of built like either of these, sort of. That's more stuff to math real quick. Magnitude of a vector xy magnitude of a vector. Square root of mag squared. Now distance just is equal to the magnitude x1 minus x naught, y1 minus y naught. Give us the magnitude of that vector. Easy peasy. Magnitude squared. All that math is the same. So, if we take the vector between the two circles, I like this part. I doubt we'll have collisions that need more adjustment than, oh, no. Find that. It's been too long. CX, CY. Times velocity normal, divide by the sum of the masses. Okay, so the normal from not the normal. I don't know why they call it normal. So let's see. Float. Could normalize. Normalize might be good. Magnitude of x and y. X divided by equals m and y. That's basically that. Radius xy, radius xy. In our case, radius also duplicates for mass. So find the normalized vector at the point of collision. See, I really hate this guy's vocabulary. Like, the point of collision is something different than what he's drawing here. So he's saying the vector between the two circles, the two circle centers, which is not the point of collision. Okay. Maybe we do start with this. Maybe we do resolve the collision, move both shapes here. I'm hoping the distance he was talking about was the distance between the two circles. But he uses this variable dist. He's calling the midpoint minus capital R. See, notice notation is defined. This is, oh, radius. Distance, okay. I think I'm correct in what that distance needs to mean. And again, he's not defining his variables. Circle 1x, circle 2x is dist. Find the norm of the vector from the point of collision for the first circle Find the norm of the vector from the point. So C2 minus C1. Which is these two delta x's, right? Delta x, delta y. Okay, we've already got these. This is that immediate response. Now we nx equals dx. The normalized vector between these. So math normalized nx and y. Hey Suki, how's it going? What's new? Let's find that normalized vector between the two things. Calculate the momentum. Momentum for A. Momentum on the x-axis for A. Do I really want to write my own math library today? Kind of not. We decided to make the compiler go the hard way, compiling directly into machine code without LLVM or any of that stuff. Yes. If I were to make some progress on my compiler, I would definitely try to avoid as many layers between me and the machine as I could. So, and you'll learn more that way, so that if in the future you have a project that requires that you use LLVM or something, you'll kind of understand what it's doing and why, because you'll have done it yourself. So, cool. That's awesome. That is awesome. Calculate the momentum value, takes into account the velocities of both circles. Momentum. Yeah, that's a great project. Ugh. I think I'm trying too hard to avoid doing math on paper on stream because you can't see it and it's not that interesting. Normalized vector between circle centers. Oh. I need to recompute these since we moved things. Okay, I think that's correct. Basically, it will create an executable directly, so no need for a linker also. Yes, because it's already integrated in the compiler. Yeah, and honestly, if you're doing single compilation unit programs, that is fine and easy and simple. The instant you start giving multiple compilation units, that part gets harder, because then you basically end up writing your own linker. But if you don't do incremental builds, then the problem gets easier again. All depends. Machine code is really hard to debug. So step one is to write a couple of tools. One which lets you see lets you pump in binary, and it writes out a human readable form, right? So for every machine code that you support, you need to be able to write it out and log it. Then you can at least see what your binary output is. Then you will know if the instructions are wrong or if you're outputting the binary wrong, right? You need to write tools. You can't work with binary without some tools. But yeah, it is really hard. Still, like I said, that's really cool. I approve. UX, UI, UI. So we can do dot product in our math thing, right? X0, Y0, X1, Y1. And that is X0 times X1 plus Y0 times Y1. Dot products are easy. So it is 2 times the difference of dot products. Math dot between velocity 1 and this normalized vector. So I don't have a way of getting velocity out just yet, but we will. I don't have tools, but I've made a YAML file with a lot of instruction sets. Yep, might do a GUI. Yeah. Anything you can do that'll let you see what the binary you outputted is intended to do. And even just test snippets and fragments. Like if you can be like, I think it's, here's the binary, paste it in, and have it kick out what it interprets it as, that might help a lot. Velocity 1, velocity 2. So I need a way to get velocities out. Okay. Velocity X, velocity Y. Pardon me. Good tooling. I'm not even saying like buy some, just write some. Anything you do will make your life easier. Because staring at hex codes, that gets rough. It can get rough. Velocity of x in the A of the A object equals A velocity x y velocity of x y. There's that dot product. N minus math dot velocity x b velocity y in the of the b object and x and y momentum of x. This is p magnitude actually. P. B is very similar. Basically the flip of this. Divided by the sum of masses, which in our case is the radius. Radius A plus radius B. A visual scripting thing for machine code would be really useful because machine code is only 1D, not 2D. I can't add \n. Nope, yep, I understand. Yeah, typing things into chat, not always great for formatting, but I understand what you mean. Yep. I'm gonna go on a quick restroom break here. But I will return shortly and continue this work and this discussion. Okay, the thing I like about my language is it's really similar to Python, but it's still like C. Yep. Yeah, you were talking me through some of those features. Pretty fun, pretty fun. It's always good to take your own ideas and implement them. Even if all you do is learn. Great. So, after the final velocity for each circle using HP value. Oh, I need this one. Velocity of x of a, the 1, I guess, equals velocity 1, so velocity xa minus p magnitude times mass 1 of that normalized, where'd that normalized go? X. Y. This one becomes plus. So what I really need then is a set velocity. So where's our move to? Oh, we have set velocity. B, 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 B. Is that it? Okay. Magnitude of total momentum. Preservation of momentum. Okay, so first we move the shapes away from the center point just enough to get them off of each other. Then we find the normalized vector between the two circle centers. Then we find the total of momentum, and that allows us to set our velocities and preserving momentum. I hope I got most of that right. Sheesh. I didn't put in mag or mag squared. One of these days, we're just going to have to write our own math libraries for vectors and such. You're in here. Okay. Okay, getting close. Oh, let's see. Quad All right, we're just hoping we're somewhat close. Collision resolution and actual physics is a bit tricky, a little painful sometimes. We'll see how we did. Okay, everything's floating away from each other. Bouncing off the walls is fine. Whoa, see? Collisions. That's not quite what we wanted. See if we can see this again. Everything's floating away from each other. Bounce. They just did weird things. Okay. Whoa. Yeah, once we get into this state, it's bad. Bad, bad, bad. Hmm. We could set up the initial conditions with 2 balls and no more. That is probably the right thing to do. So we take our number of bubbles. We're just going to take 2. End it. So that initializes everything. Set bounds. This is the last piece. So all we need to do for testing is this. Since we're going to underscore bubbles, so 0, move 2, we're going to move everything along the center axis. It's going to be this. This is just for quick and dirty testing, so it can be not great. Bubble 1. We go to the center X minus that much. There we go. That's what I want. And plus that much. Then we want to underscore bubbles. So 0, not set. Velocity. And since we're negative, we want to be pointed this way. So let's go 25, 0. This one wants to go the exact opposite direction. Minus 25, that way. Try that on. Let's see here. Let's see here. I also re-implemented most every single part of string. Yep, in pure calcium. Nice. Even made my own malloc function. Cool. What are you using for your? Well, malloc itself isn't that hard. It's the malloc and free combination. Things get complicated, preventing memory fragmentation, etc. What kind of allocation and kind of memory management scheme we're using, like a mark and sweep or what? I'm always curious about such things. I think mark and sweep is the only one I can think of off the top of my head right now. No, there's other schemes. I don't remember their names. Okay, so they're coming towards each other. and nothing. Wow. Those didn't collide at all. Why is that? Why, oh why? To remove testing only. Bubbles collided. If it even detects the collision correctly. Okay, made a simple query. Okay, alright. Oh, cool video on how to implement your own malloc. I have not gone around to using it, and it's bookmarked on my other account. But it is another project I need to throw on my list. Okay, so they are both cleared for collisions. And they're not detecting each other. Well, shoot. Shoot. Both got cleared. Oops. That might be more important. We'll try that. Oi. Where are we at? 4:30. I kind of expect both of them to collide now. There it goes. Okay. So they collided. That's fine. And now they're going to resolve somehow. XY, move 2. Moving away from center point. So the center, 0.3f, 0.3f. X sub m, y sub m. Alright, we're going to cheat one other way. We're going to turn off collision. Inside the collision resolution. So we're going to touch, it's going to say we collided, and then we're going to turn it off so they pass all the way through each other. Then they'll re-clear once they're through. We're going to try that. When we mark as collidable, this will go away, clear if it's collidable. Okay, now I can just do it, and then in resolve bubble, clear, collidable, and the other bubble is also cleared up. I just want to see which direction they go after that. Two bubbles approaching. They hit. And strange things happened. Hit. Oh, interesting. Let's reset all that. That first collision does some very strange things. So we expect the big one to bounce that way and the little one to bounce that way. I would argue that the A, B center point. Then we're going to move them. So AB center point, then we're going to move away from the center point by some amount. That would all be very instructive. Our Y might be upside down. Honestly, this math here, they should both be at the same y-axis in the first place, so there should be no dy. Let's check it out. Maybe we have a typo somewhere, which means we have invalid data being computed. Okay, so A was here, B was here. The center point is nowhere near that or that. Center point should be between these 2 points and this 2 points. Okay, that's bizarre. So already even computing our center point is wrong. That doesn't bode well. Oh, parentheses. Parentheses are important. That will make a huge difference. Yeah, so memory allocators are simple enough if you don't care about performance, right? You just say, go look for a block of memory inside of, so you get a block of memory, a page from the computer. And you say, I want to divvy this up. And somebody requests it from you, and you find an appropriate sized chunk inside there and say, here's the address. We promise you this is yours, not anything we're just going to touch until you let it go. And that's wonderful and great. But then, when you run out of memory, obviously that's a problem. So you need to go give it back. As long as you don't care about giving it back, trivial. You just, march forward this much, hand it to him, go. Hand this much to him, go. And like that's a very most simplistic one. But if you need to give it back, then you need to mark that block as being available. And once you do that, now you start getting fragmentation. Well, this block doesn't really hold that, so I need to get a block from somewhere else. Oh, hey, that looks better. Okay, so that part's better. We get our new positions. Normalize velocities. Think. Oh wait. One of these needs to be plus. We'll try this one as plus. We may end up having to invert the y-axis, but it'll be fine. So if you hand back lots of pieces and you're filling in between with small allocations, you can fragment it to the point where each of the slices that you've sliced up your memory into is too small to give back out for a larger allocation. So periodically you have to do what's called coalesce, where you go through your memory and say, all these little tiny pieces that are next to each other that aren't being used, combine them back into one large block, right? I'm keeping track of those. As long as you always allocate the same size of thing, it's not a problem, right? If everything you allocate is 32 bytes, then you never have to coalesce, right? But you're going to allocate some small things, you're going to allocate some big things. You'll fragment your memory. You have to coalesce to get that all back into large blocks that you can subdivide again. Here we go. When do you coalesce? How do you know you need to? Oh! Was that it? It didn't look great, but we're going to have another collision here in a second. I would expect the small one to pick up more of the energy. And it kind of did. Now it's going to run it over. Okay, it's kind of working. I'm thinking I don't want to actually do this. What if we don't do this? Yes, I know distance is not used anymore. We'll try that out. That's one of my complaints about Java is the garbage collector, right? Let's say you're running a game, you need to run at 60 frames per second. How do you know when the garbage collector is going to fire? You could be playing along in the middle of a heated firefight, and then the garbage collector will take over, and you have no control over that. You don't know when the garbage collector is going to fire, or how long it's going to take, ever. So it's now become a game about working around Java features to trick Java into not running the garbage collector unless you want it to. So you're gonna create memory in places where it will never be freed, which, guess what? It's what you were probably gonna do in C anyways, if you needed performance. You're gonna create a big old block of memory and tell Java never to touch it. Or, create the reference counting situation where never will be. Oh, that looks good. Okay. Let's try that. Let's remove the logging. We don't like this one anymore. I didn't like that one. Keep that one there. It's fine. Bubbles collided. We can leave that logging in as well, right? Yeah, let's quit. Let's go back to the testing. Remove this for testing only. We're gonna put in the normal one. I'm gonna change our number back to 12 or something. So a cleanup build, make sure it's still running. Okay, well, it worked on the x-axis. If you need to test against like the y-axis or against 45 degrees or incidental hits, we can set up all those situations. But for now, we're just gonna see what happens. The fact that it worked on the x-axis is encouraging. Just have time to start working on the pop. Unused variables, that's fine. We use dx? I don't think we do. Oh. There it is. I don't think we use dx otherwise. Okay. And we run it. Oh. See, those two are very, very inextricably locked. So we're gonna have to fix that. Because we're getting too many bubbles stuck on themselves. There are some collisions happening. Oh, this one's almost ready to have collisions. There it goes. Now it can collide. Donk. This one is taking forever to desync their positions. Alright, we gotta go fix that. Bubbles. When we init. Thirty divided by 12 is 4 degrees. Maybe we pass in the angle. Maybe take 30, 45, 60. 3. And there are 4 of those, so 1 in each quadrant. I mean, 12 may not even be the amount we end up with, but we can at least cheap and dirty this in there. Let's just do that. Init. Double. Or float. Heading angle. Heading angle. Means when we init, we can do the following. We can do 30 plus 15 times index modulus 3 You're gonna love this. It's gonna be great. 15.0 times index modulus 3. So it'll be 30, 45, 60. Plus index divided by 4. So let's see here. 30, 90, 120 times, oh no, plus 90 times that. Okay, so it'll be 0, 0, 0 plus 30, 45, 60. Then it'll be 90 plus 30, 45, 60. We're going to try that. We're going to shoot them in every direction indiscriminately. Instead of randomizing the heading. That actually looks better. Except there are still balls that overlap. How can that even happen? Mostly that looks pretty good though, honestly. Bonk. I still feel like big objects are picking up more speed than small objects. Still not bad. Not bad. Not journal. To do. Fish tank. Chalk or on top of bookshelf. Like I said, there are so many ideas. Okay. Okay, so clearing things for collisions. I guess we're done. Let's quit that for now. We don't need that anymore. We really don't like that. At hard velocities, we don't need to do this resolution. Not bad, not bad. Cleared. Okay. So that's like most of our issues, except for this one. Zero times 15 plus 30 plus nothing. 1 times 15 plus 30 is 45 plus nothing. 2, 30, 60 plus nothing. When we hit 4, oh, we hit 3. I think it's divided by 3. Not 4. That might fix it. So everything's going to fly off in completely separate directions. And only when they come back are they going to start colliding. I think that's reasonable. Oh. Honestly, considering we just made an entire physics thing in an afternoon, circle collisions, that's not bad. Between the bouncy ball with our first order Euler integrators and the bubbles with the collision detection and resolution, we actually have, that's not what I would expect. Curious. We're still sub 1 millisecond frames, even with all of the physics. Not that it's that much physics, but not that we've optimized it either. I think these big ones are picking up too much magnitude. I think the directions are correct. It feels like the little ones should pick up more velocity. I think. It feels like the smaller object should be picking up more speed. Well, sometimes they do. It's kind of hard to gauge. Let's watch this small one. get run over by a huge... Oh, it missed. Here's a... I don't know. Overall, that's pretty satisfying. Let's call that good. Okay, so we want to go pop. It will not call fade out. Here. I think this needs to happen either way. Maybe we just try that. Music is already being done. Okay, let's check this for a test drive, see how we're doing. Okay. I like that there's no energy loss because of preservation of momentum, so nothing will ever stop moving. What? Why are there so many in this quadrant? And these are still stuck together. That initial heading is a lie. Oh, I was going to test that thing. Oh well. Enable init angle. We pass in a heading angle. You know what? Let's log it. Log. No. Actually, let's do it up here where we call it init. Bubble 0.3f index angle. All right. What's wrong with those angles? They should all fly off in different directions. 3 should have that quadrant, 3 should have that quadrant. It should be beautiful. That's my argument. Take a look. $30, $45, $60. So there's 3 that way, 4 that way, 3, 2. These angles look right. 34, 5, 60, 120, 35, 50, 210, 225, 243. Those angles are right. So then what's happening? We set size, we set color, we set how fast it shifts colors. We get the angle. We get a speed. Velocity is speed with a direction. Speed times cosine. Speed times sine. Oh, we no longer do this. That's my problem. I forgot we put that in to try to spread things out. My bad. That'll fix it. Now we will get rapid divergence, no overlaps after the first second or two. Oh. It will look less natural, but it'll be fine. We can even add random 5 or plus or minus 5 degree angles to everything. But I don't know if we want to. Oh, it's beautiful. Cool. Yeah, still plenty of FPS to play with. Okay. Bubbles now have physics. Oh, I was going to test the thing. I've trained myself to just click the X instead of exit the scene. I think I can do this. The bubbles all appear, they flying around. When we hit exit, yeah, they just disabled. Okay. All right, we're gonna call that good. Bubble collision. Bubbles have collision detection and resolution. Bounce around all energy conserved. Perfect elastic bounce. That is very calm, actually. I like the way that it looks. That was a good suggestion there, JTL. All right. To start, we're just going to disappear and play popsing. Oh, let's go to, I want to do a small thing here. Not doing that. Oops. This testing only goes away. The physics are all good. Not good enough. Okay. Got all the collision stuff we need. Okay. All right. Now, let me init. Enable. Right here. So our 0th one, we start with the no velocity, go up to our active velocity. We animate our size from 0 to 3, and then we immediately start the color change. We're going to make 2 more stages for this. Sequence .2 set, wait, stage 0, URNG, next float, up to 3.0. So, actually, I don't even know if we want that much. 1 second. Then at stage 1, we do that. 0, 1, 2, 3. Okay. Almost have an encyclopedia set for you. Oh, nice. Nice. That will look good. Encyclopedias are good. I read them as a child. Instead of all of them appearing at the same time, they'll have a bit of a stagger for their launch. Cool. Just because we can. That little one is so sad over there. These bubbles are going too far, some of them. I wonder why. Okay. That was part 1. We want a little bit of a random startup for each bubble. Disable. We're kind of gonna do the same thing, except we're gonna make it more and more complicated as we go. So. And now, the last piece, sequence .2 set play sound. I mean, we can just say start sound. But then we need a sound for it. Scheduler get sound from the sound warehouse asset, and we want pop. I don't remember if that's what it's called. Assets sounds pop. Lowercase. Because we are not consistent. That's it. I guess we only need 2 things for now. In update, if enabled, I want to check afterwards. Bool is done taking false true if underscore bubbles at that index is enabled, then is done equals false. We're not done as long as any of the bubbles are active. And break. If we are done, enable equals false. There's no point in running anything if we're done. Okay, so fade out. Each bubble will be disabled. the other thing is right click bubble at the index. Bubble at the index dot disable. We're going to try that out. That might just almost work. For the fade out, we want to add another layer of random offset to it. So we can do that a couple ways. Let's see what we do. Huh. Okay. I think I know what's going on. Fade in. Enable equals true. Enable the buttons. Bubbles. Where's our update? Otherwise, if we are not done, turn it on. If there's any bubble active, we'll go back into active mode. So that's when you can right mouse click to delete all of them or to pop them all. When they're gone, they're gone. There goes the bubbles. Lovely. And then we can right click to pop. And it blows up. Cool. Means we set it up wrong. Disable. Two-step. Oh. 0 and 1. Actually, disable, enable. Random wait. Ooh, random wait. Enable. No. True. True. Random wait. Three. Set immediate 1 and 2. Now we right click. Does not have random wait. That's basically the only change there. Oh, 520. I think we'll get done what I wanted to get done today, including the added bubble physics that we added, even though that wasn't required. It does look very nice, though. That was a nice touch, a nice add. Okay. Oops. Okay, well, we got a thing to fix there. Let all the bubbles pop out, and then... Oh, that's not bad. That is not bad at all. I do not mind that. Okay. Disable. Or fade out. If the bubble at index is enabled, then we disable it. Yes, that's very nice. I think the bubbles popping is a nice little touch. I don't even think we need the sprite animation for the pop. I think it looks, although it would be kind of cool. Would it be cool enough? Is it cool enough to bother with? Those bubbles are so satisfying. The way they float about. One, two, three, four. Not bad, not bad. Okay. And if we kill all of them, we should not hear another sound on exit. Ah, that did give me two at once. It uses the click trainer. No bubbles. Okay, good. And if we leave with all of them fully active, oh, that's nice. I think we're good. I think we're good. I don't think we need a sprite animation for that. I'm not even sure we need these action sequences to terminate. Not really needed. And yes, okay. Right clicking bubbles, pops them. Leaving game scene, pops them all. I think that's it. Like, that was not bad. All right. Get restore staged. Oh, that's not what I wanted to do. Bubbles now pop on right click and when exiting the level. People will spend more time with bubbles than solving word puzzles. Exactly. How else can I have any inch spot out on the leaderboards if I don't keep people distracted? I think that's great. I think we did it. We've done that. Looks like they're all to-do list. We could have fish swimming around in the chalkboard. I don't really think so. I think the bubble does the job. A non-interruptible poster hanging off the front of the table could actually be very, very nice. We're not putting anything on the bookshelf yet. If we're going to do chalk stuff, we're going to keep doing chalk stuff for a little bit longer. There's a lamp maybe we could turn on and off. I don't know. I do like the idea of this. If we did get a stick of chalk on the chalk tray, you could, and an eraser on the chalk tray, we could click on the eraser, and that would erase the current chalk doodad. If you click the stick of chalk, then you click on the the stick of chalk. It would put a new random doodad on the board. I think that would be kind of fun. Random static posters. I actually really like that. I can build up a nice little word of the day and quotes file. We have a solar system. It's not really interactable. Oh. Solar system. I mean, yeah, the chalkboard is just so fun to play with, actually. I'm kind of liking it. Dirt, seed, sun, watering can. See, I want to do this one. This one might be moving up. I like the idea of this one too. A catapult with like a chalk drawing of a catapult and a castle chalk drawing. And then you right click the catapult, and as long as you hold it, well, let's see here. You can use the two axes of the mouse to aim and to charge your catapult. And then when you let go, it fires the shot. You do a similar thing with an archer, like just a stick figure archer. And they would stick in the sides of the blackboard. That could be kind of fun. Solar system. You just have a chalk drawing of a solar system where everything is going around. Clamped inside. We could do a steam engine or a fish tank in the chalkboard, or not in the chalkboard. Unclear. I know between my music composer making wonderful music for me, some good doodads, and some decent art coming out of you, this might actually be a decent game. Quotes and words of the day. Now this will be my list of words of the day, not served off of some web page, so I'll have to go dig that up. I have text documents of fun words. I would have to make sure they all fit on the poster. We would need quite a few. It would be every time you start a new game, that poster would pop up. Okay. No, I'm actually not opposed to this. I think the table, as nice as it looks, there's like dead space underneath it. So do we add something interesting under there? Little poster. It's an optional thing, so it doesn't really matter. Let's do that. We 5:30. We probably won't get very far. Non-interactable poster doodad hanging off the front of the table with quote or word of the day. Okay. So what we're gonna do is we're going to game scene. Oh, hum. I need to know the distance. From about there to about there, and then from about, oh, where's the table? Sorry, I'm just trying to get a dimension off the image of the table, so I'll know where to put the poster. We need to know this number. To about that number, right about there. Then you have the poster hang down quite a ways. Now, if I use the rectangle select, I can get a width and a height. Maybe I should share the GIMP screen so you can at least see what I'm measuring off of, but maybe it doesn't matter. I'll share GIMP. I can't share my notebook. GIMP. There we go. Right, so I've got this rectangle here. Maybe I'll change that. I don't know. Let's see. Maybe we can have a staple. Depending on the quote or the word of the day, this doesn't need to be quite so big. Option 2, we could, I don't know. Width, height. Oh, okay. So our width is 861, 161. The X and Y, it's 113, 16, 28 minus that top corner. 1450 and 62. 13 minus 62, so that'd be at 51 off the corner of the table, and 1628 minus 1450 of the table is 178. Okay, we have our dimensions. So we can hide GIMP. Source, doodad of the day. And it does not need much work. This is not animated, not interactable. Maybe we'll play a sound when you click on it. I don't know. Like in Hearthstone, if you click inside the arena, it's just a little dirt thwip. Sounded pretty good. So maybe something simple like that. But like, there's not going to be anywhere near the level of care for this one. Chalk. Bubbles. Because a lot of this is going to be very similar. We need some of this, not all of it. We don't need CMath. We need the game context. We need to find. We currently don't need the texture quad average warehouse for now. Mouse press event. Sure, like I said, make it a whip. There's no input. There's no scheduler needed right now. There's nothing time related. No animation. There's no action sequence. Maybe we use the scheduler. Scheduler's in the list twice, huh? That's always awkward. We do need randomness. I don't think we need math. Okay. Public fine. Update and render. There is no update. There's just render. That's it. Pick text. I think that's it. Set const float. Well, no, we're not doing it that way either. Doodad of the day. Barnet. Huh? Not spell. That's okay. We're going to start off with a color quad. We're going to do this up fast and dirty today. And we need text. That's it. We have a texture quad. And our text. Pick text. The other thing we need to steal out of pop bubbles is initialization. You might as well put this in, right? We will need those random things eventually. Hit render. Thing needs 2 children. If you have time, sent encyclopedias, the whole alphabet will be there when I'm done. Oh, cool, cool. Do I have time? Do I have time? I started a few minutes late. So sure, like doodad of the day is not going to compile or affect anything, so I can sideline that. Let me go check the old email. There it is, encyclopedia test, scene elements 1, we download. Save. Okay, let's go move the thing. I come over here. I'm gonna move the file over. Downloads. To active projects, word sleuth, assets, images, layout scene elements 1, rev 1, move here. Okay. Now I open it in GIMP and share the GIMP. Okay. Ooh, nice. We have an alphabet. Cool. Okay. I'm just going to export as scene elements 1. I don't even think I need to do anything, probably. Okay, that's basically it, I think. Okay, so go over here. The tools bin / embed PNGs. Come back up. While that's working away, we click our make file and say, please do the image warehouse. Usually I'd suppress that, but tidy things up and build. Nice. Okay with that design? Oh yeah, it looks good. I can change colors, etc. if needed there based on the version I had growing up. I'm not married to the color scheme. Yeah, that's fair. We're gonna see how it looks contrasted on the bookshelf. I'll do the old blurred vision test. Let's see how it looks going on and off the shelf. While we're doing that, we should add it to the old journal. Test new books. On bookshelf. I should say that. There we go. All right, building, building, building. Yeah, no, ours growing up, it was the old World Book Encyclopedia. I think the 1984 edition that I grew up with. It had like that maroon with like a beige stripe, but a very similar pattern to what your test should. Yeah, similar pattern, just more of a maroon than a tan. I certainly wasn't married to that color scheme either, but the brown on wood, that is a different enough brown. I think you get away with it just fine on those wood textures. Okay, taking it for a test drive. We may even still have time to finish the word of the day poster. The doodad of the day. Okay. So there's your dictionaries. We only have 4 sets of books. Nice. I need to like randomize these, but so I'm going to replay. Is replay broken? I mean, not broken, but go back a word. Huh. Reset. Oh, come on, replay. What's going on here? Replay seems to be broken. Shoot. Yeah, the only thing I would say is it actually looks like they might be a little bit too tall. We do have a bug in that replay. Okay, well, maybe another bug in the replay. We'll add it to the old to-do list. Bug replay. Replay won't. Reset or navigate by word, period. Okay, well, yeah, they might actually be a little too tall. Like if you could shorten them so that the top of the book is just peeking out from the shelf above. Let's see here. It's like if there could just be like a little bit of that white showing at the top of one of the books of the encyclopedias. Not this much maybe even, but just a little bit of that spine and white pages. I think that would help break it up. What do you think of that brown on brown? Oh, I can make it bigger since you need to see the visual. Make the game bigger. Oh, there's something like that. It is a different brown. What do you think? Is that different enough of a brown? Can shorten. Brown kind of hides. Yeah, I don't know if I want anything super bright, but I don't know what I would pick that would contrast. So I'll leave that up to your artistic discretion. But overall, I'm liking it. That looks way better than my hyper-colored books over here. Cool. I like it. Ooh, here's an idea for me. Oh, anyway, that's fine. It doesn't matter. Can you screenshot that from my end? Yes, yes, I can. Yeah, it'll be a much larger image if I do it this way. So let me just cheat out a couple of levels so you can see how it looks on not just the top shelf, but the next shelf below as well. Might as well just fill it up, right? 4 and 5. Okay. Print screen. Let me go to the old GIMP. Make a new image. 1920 by 10. Oh, by 1440. Paste. Good enough. Export as Encyclopedia on. Nope, I don't want to put it there. I want to put it on the desktop. There we go. All right, coming your way in just a minute. Let me finish exporting that. Reply as requested. Boom. Send. Like I said, still better than what I've got right now, so I'm not quite pleased. I'm quite pleased with it. I might make the pop a little bit quieter. Four. That won't change anything just yet, but it's fine. Okay, back to the old doodad of the day. Okay, render. Add file underscore quad and text. All right, so the quad size. If enabled, set texture. Oh no, set color. We're just gonna start with straight up white. I want the poster attached to the table. Move to, I wrote that number down, it's 51,178. 51,178. Oh, we might as well set a rectangle, right? Fifty-one, 178. The width was 861. The height was 161. That's basically it for the quad. You know what we could do? We could do this right. Quad then check. Okay. m_quad this m_text this. That just simplifies things a bit, I think. Then this comes back here. m_text dot set text color. We're just going with go black. Text dot set rectangle can be the same rectangle, m_quad rectangle. m_text dot set something. Set alignment text v align. Center it for now. Call that good. Set font size. No idea. Doesn't matter. Text dot set text. Word of the day. Despair. This isn't the kind of thing I'd actually put in there. We just want to see how it looks. Okay, doodad of the day. Text actually. You can just stub these out anyways. That'll be fine. I'm going to not use the random number generator for now. We're just going to hard code something. Pick text. Okay, that's one. And then handle mouse press is going to do nothing essentially. We're going to copy the stub out of doodad here. Bubble. If it's enabled, etc., etc. Turn result. Good enough for now. Or right click. Log note. Poster right click. All right, is there anything else we need here? Maybe the white and maroon versions. Yeah, maybe. I wonder if like there can be like the light band and the light at the top and at the bottom of the book. So there's like light band, maroon or brown, light band where the letter goes, dark band, then a light band at the bottom. Maybe that helps separate it, even if you use the brown. I don't know. So right now it's dark brown, dark brown, dark. I don't know. I don't know if that would help at all. Anyway. What was I thinking? Sorry, too many thoughts. Too spread out, too. Okay, so table game scene. That's where we need to go. Table. Oh wait, we need to go to doodads. Doodad of the day. Doodad of the day. Bubbles. We need to render. Although this needs to happen after table. It can happen after all the table stuff. Much for table. Okay. Game scene. Table. Current guess character index. No pointer, but it does need one child, or it can have one child. Table. Add child. Oh wait. Doodad is one of the last things to come in. So m_doodad of the day given the address of m_table. That's what I want. Maybe. Oh, bother. Maybe. They just want this to follow the table. That's really the only reason for this. Of the day. Well, let's just see what happens. Okay, but this is it. This is our last test. If we get anything to show up, victory. If not, we'll pick up there tomorrow. Oh, wait. No, we're not picking up there tomorrow. Oh, yes, we are picking up there tomorrow. Tomorrow's Thursday. Good, good, good. That's not going to work. Because we didn't do this. Hmm. Oh, not texture quad. Color quad. Mostly just small text. No matching function. Via line, via line. What? Oh, I see. I know what's going on. H align. Oh, set text size, huh? All right. Gonna compile. No. Good old incremental builds. Oh, yeah. Oh. Not too shabby. Then tomorrow would just be about putting together a big list of words and quotes and seeing how they fit. Then we have to build up a little dictionary of font sizes accompanying our text. So we'll have basically an array of texts, an array of sizes. I don't know how many. Couple hundred, couple thousand. I'm sure there are lists around that I can pillage. This is one of those low, not low effort, but low. Okay, it's not here. That may be okay. Because we start off disabled and we turn it on in game scene. Fade in. Basically we want this, but in init elements where we do of the day. Oh. Table. I really like it if it just showed up where I wanted and threw some text on the screen. Doesn't have to look good. We didn't even set the font. It'll probably be that marker font. Hey, it's close. You know, that's good enough for where we're at. That's definitely not right, but not bad either. Okay, cool. We're gonna call it good there. And at least it's on the screen and in the general right area. So we're gonna call that a partial win. The new book on the shelf. Let's see here. Tested new books on the shelf. Much better than the old ones. Some changes still pending. Poster dubbed in. It displays adjustments needed and a long list of things to put there and their sizes. We'll probably pick up there tomorrow. Let's grab that real quick. 21. Tasks and notes. Doodad of the day. Fix the positioning. Size and so forth. Add list of words. Adjustments needed. See tasks for tomorrow. That's probably better than add list of words, quotes, and their font sizes. Randomly pick some. Something for me to consider tonight. Doodad of the day. Holiday variations. Different list of words. Different poster image color. Unclear. I think we may not do a lot of holiday stuff just so we can get it out of the day, out of the door, and then we'll just update later with holiday stuff. So, okay, thanks for everything, everybody. You have a wonderful evening. We'll talk to you tomorrow. Oh, you gotta add these files. Started the doodad of the day. Good enough. Okay, yep, thanks. You have a wonderful evening. We'll talk to you tomorrow. See ya.